When we look up into the quiet darkness of the night sky, it's easy to feel as if the stars above are all there is, a shimmering dome of light gently wrapping our small world in mystery. Yet what our eyes see is only the faintest fraction of reality. Most of those stars belong to our own galaxy, the Milky Way, a sprawling island of light adrift in a cosmic ocean so vast that even the most imaginative mind struggles to comprehend it. And beyond that shimmering river of stars lies something even greater, a universe brimming with countless galaxies, each one a story of its own, each one a flicker in the grand tapestry of existence. Our Milky Way is immense beyond human measure, 100,000 light-years wide, with hundreds of billions of suns scattered across its spiraling arms. It's a structure of breathtaking complexity, a city of stars, gas, dust, and invisible matter bound together by gravity's unseen hand. Yet in the scale of the universe, it is nothing more than a small province within an empire too vast to chart. The nearest great galaxy, Andromeda, glows faintly in our sky, a smudge of light 2.5 million light-years away. When we see it, we are witnessing ancient light, a message that began its journey when early humans were little more than tool makers wandering under unfamiliar skies. Andromeda is larger than our galaxy, containing perhaps 1 trillion stars. In time, roughly 4.5 billion years from now, the two galaxies will slowly draw together, their gravitational attraction pulling them into an elegant, spiraling dance that will eventually fuse them into one massive elliptical galaxy. Astronomers have already named their future union, Milkomeda. It sounds poetic, doesn't it? A single, grand world of stars born from the merger of two ancient spirals. But even that union, as colossal as it seems, will be only one small event within a universe teeming with structures that dwarf imagination. Our Milky Way and Andromeda, along with dozens of smaller companions, belong to what astronomers call the local group, a small community of around 80 galaxies bound together by mutual gravity. The local group itself is part of a much larger structure known as the Virgo supercluster, home to over 1,000 galaxies spread across a span of more than 100 million light-years. To put that into perspective, if the Milky Way were the size of a coin, the Virgo supercluster would stretch larger than a football field. And yet that is far from the full picture. With powerful telescopes, astronomers have discovered that the observable universe contains perhaps 2 trillion galaxies. 2 trillion. Each one an immense congregation of stars, planets, and cosmic dust, entire ecosystems of light and matter scattered across an expanse so vast that light itself, the fastest thing we know, takes billions of years to cross it. Every direction we look reveals more galaxies, stretching outward in layers upon layers of cosmic time, each one glowing faintly from its place in the distant past. The Hubble Space Telescope gave us one of the most profound glimpses into that immensity. When it was pointed at what appeared to be an empty patch of sky, a place where no visible stars shone, it captured an image that changed our perspective forever. That seemingly blank region bloomed into thousands of galaxies, each one a tiny jewel suspended in darkness. Some of them were so far away that their light began its journey when the universe was only a few 100 million years old.
What those images revealed is that the universe isn't a random scattering of stars. Galaxies arrange themselves into patterns. Long filaments, vast walls, and immense clusters, separated by enormous voids. It's as though the cosmos itself has a hidden skeleton, an invisible web that shapes where matter gathers and where it does not. Astronomers call this grand design the cosmic web, a network stretching across billions of light years. Within this web lie enormous regions of near emptiness called cosmic voids, places where galaxies are rare and matter is scarce. The largest of them, like the Boötes void, spans hundreds of millions of light years across, vast spaces containing almost nothing at all. If we lived inside such a void, the night sky would appear strangely empty. We might never have discovered that other galaxies existed, perhaps believing for millennia that our Milky Way was the entire universe. These voids and filaments are shaped by a mysterious ingredient, dark matter. We cannot see it, yet it reveals itself through gravity, the subtle bending of light, the motion of galaxies, the structure of the universe itself. Dark matter forms the scaffolding upon which all visible galaxies are built. It's the invisible architecture of the cosmos, guiding the birth of stars and the clustering of galaxies across cosmic time. And then there's dark energy, an even stranger force. In the late 1990s, astronomers discovered that the universe's expansion wasn't slowing down as expected. It was accelerating. Something unseen was pushing space apart, stretching it faster and faster as billions of years pass. We don't know what dark energy truly is. It makes up nearly 70% of everything. Yet it remains as mysterious today as the first moment it was discovered. It's as if the universe itself is being pulled outward by a force that defies comprehension, rewriting our understanding of destiny on a cosmic scale. The more we explore, the more the universe seems to mirror both chaos and order, beauty and emptiness intertwined. Galaxies collide, merge and reform in slow-motion ballets that last billions of years. Stars are born from clouds of dust and gas, burn brilliantly, then die in explosions that forge the elements needed for life. Supernovae scatter those elements into space, where they gather again, forming new generations of stars and planets. A never-ending cycle of destruction and renewal. Through all this, we've managed to map the vast distances between galaxies using clever techniques. It began with the work of Henrietta Swan Leavitt in the early 1900s, who discovered that certain stars, Cepheid variables, pulsate with brightness that can be used as a cosmic measuring stick. Edwin Hubble later used this discovery to prove that Andromeda was far beyond our galaxy, confirming that the Milky Way was just one island among many. Since then, scientists have built what they call the cosmic distance ladder, a hierarchy of methods that stretch from nearby stars to the most distant galaxies. Type A supernovae, for instance, serve as brilliant standard candles visible across billions of light years. By studying them, we've learned that the universe's expansion is not just steady, but accelerating, propelled by the mysterious dark energy that fills space. As we venture deeper into the cosmos, the sheer ingenuity of how humanity has managed to measure the immeasurable becomes clear. We have found ways to read the universe like an ancient manuscript, deciphering meaning from faint glimmers of light that have traveled for billions of years. Every wavelength, every pulse, every distortion carries a story about distance, time, and matter. We have learned to turn that language of light into a map, a cosmic cartography that reveals the structure of everything that exists. It is both a triumph of science and an act of quiet reverence. Long ago, astronomers struggled to understand how far the stars truly were. For centuries, the heavens were thought to be fixed and nearby, a glittering ceiling rather than an unfathomable depth. Then came a revelation that distance itself could be measured through light. Parallax, the tiny shift in a star's apparent position as Earth moves around the Sun, allowed us to calculate the distance to our stellar neighbors. It was the first rung of what would become a vast ladder, reaching all the way to the edge of the observable universe. From there, methods grew ever more ingenious. Variable stars, supernovae, redshifts, each one adding another step toward the infinite. The redshift of galaxies, that gentle stretching of light toward longer wavelengths, tells us that the universe is expanding. It's not that galaxies are moving through space like ships on a sea. Rather, space itself is swelling, carrying galaxies apart. The farther away a galaxy lies, the faster it recedes. This relationship, discovered by Edwin Hubble, became one of the cornerstones of modern cosmology. It means that the universe had a beginning, that time and space themselves emerged together in a great expansion we now call the Big Bang. To gaze into the depths of space is to look backward in time. The light reaching us from distant galaxies began its journey long before Earth formed. Some of the photons entering your eyes right now may have been traveling since before there were any stars at all, since the first atoms began to cool out of the cosmic fire. The telescope becomes not just an instrument of sight, but of memory, a device that lets us witness the earliest chapters of creation. The Hubble Deep Field image is one of those rare moments when humanity caught a glimpse of eternity. Astronomers chose a patch of sky so small that it seemed empty, no larger than the tip of a needle held at arm's length. For days, Hubble stared into that darkness, gathering light patiently, photon by photon. When the data were assembled, the darkness blossomed into thousands of galaxies. Every speck, every smear of color was a world beyond comprehension. Some were so far away that they existed when the universe was still in its infancy, when the first heavy elements were only just being forged. That image was not just a photograph, it was a revelation. It told us that even the emptiest places are filled with wonders invisible to the naked eye. And yet, for all the galaxies and all the light, most of the universe remains unseen. The cosmic web that underlies everything is woven from dark matter, invisible yet indispensable. Without it, galaxies could not form, stars would not cluster, and the grand architecture of the cosmos would never have taken shape. We cannot touch it or see it directly, but we know it's there through its gravity. It tugs at starlight, bends space, and sculpts the universe on scales far beyond imagination. The voids, though seemingly empty, have their own quiet majesty. Imagine drifting through one, hundreds of millions of light years wide, with only a handful of faint galaxies scattered across the darkness. In such a place, the concept of distance loses meaning. The nearest star would be so far that light itself would seem slow. Yet even there, thin traces of hydrogen whisper through the void, the last remnants of matter too diffuse to form stars. Space may appear silent, but it is never truly empty. Within the clusters where galaxies gather, another story unfolds. The Coma cluster, for example, contains thousands of galaxies bound together in a slow gravitational waltz. They collide, merge, and reshape each other over billions of years. These colossal interactions ignite bursts of star formation or strip galaxies of their gas entirely, leaving behind ancient, quiet systems of old stars. The scale of these events is staggering. Entire galaxies moving at millions of kilometers per hour, yet so far apart that their stars rarely collide. From our perspective, the dance is almost serene, unfolding over cosmic ages too vast for human minds to track. Our own Milky Way is part of that endless cycle. Even now, it feeds on smaller satellite galaxies, pulling them apart and weaving their stars into its spiral arms. Streams of ancient stars, remnants of consumed galaxies, wrap around us like faint celestial ribbons. It's a quiet reminder that creation and destruction are inseparable in the story of the cosmos. And through all of this, the universe keeps expanding. The discovery that this expansion is accelerating shook the foundations of cosmology. The force driving it, dark energy, is the most mysterious phenomenon we know. It acts like a pressure inherent to space itself, countering gravity and pushing galaxies apart faster and faster. One day, in the far future, that acceleration will stretch the cosmos so much that distant galaxies will slip beyond our ability to see them. Future astronomers, if any remain, will look up and find themselves in a dark, lonely sky, unaware that an entire universe once shone beyond their reach. It's a sobering thought that the deeper truths of existence may become inaccessible simply because of the passage of time. We live at a privileged moment when the cosmos is still visible, when light from distant galaxies still reaches us. We can study the early universe by watching ancient photons arrive, carrying their stories across eons. But that window will not stay open forever. Perhaps that impermanence is what gives this exploration its beauty. The universe is not only vast, it is fleeting in its visibility. We are witnesses to a particular moment in its history, able to see just enough to understand how extraordinary it truly is. Every discovery, every image of a distant galaxy, every spectrum, every subtle gravitational lens is a fragment of a story that will someday fade from view. Still, our curiosity presses onward. The Sloan Digital Survey and other projects have mapped millions of galaxies in 3 dimensions, revealing the cosmic web in exquisite detail. Looking at those maps feels almost biological. The Great Attractor, a hidden concentration of mass toward which our local group and thousands of other galaxies seem to be moving, lies obscured behind the dense plain of the Milky Way. We cannot see it directly, but its gravitational pull tugs at us, guiding the motion of our entire galactic neighborhood.
Every star we see in the night sky is a chapter in the universe's long, unfolding story. Each one is a luminous island of fusion, born from the quiet collapse of gas and dust under gravity's patient pull. Within vast nebulae, immense clouds stretching across light years, matter gathers, slowly densifying until the pressure at the core grows fierce enough to ignite nuclear fire. Hydrogen atoms fuse into helium, releasing light and heat that push outward against gravity's inward pull. That balance creates the gentle stability we call a star. For millions, sometimes billions of years, that balance holds. Stars live their lives as engines of creation, quietly turning matter into energy, sustaining worlds and shaping galaxies. The light of our sun, for example, has been shining steadily for over 4.5 billion years, warming our planet, fueling photosynthesis and giving life its rhythm. It burns hydrogen at such a slow, deliberate pace that it has enough fuel to continue shining for another 5 billion years. Yet, even the most enduring stars must eventually exhaust their supply of hydrogen, and when they do, the universe changes in profound ways. When a star's core runs out of hydrogen, the fusion slows, gravity tightens its grip, and the outer layers begin to swell. A small sun-like star will expand into a red giant, growing so large that it could engulf nearby planets. Its outer layers drift away, forming ethereal shells of glowing gas, what we call planetary nebulae. At the center, the star's core collapses into a dense Earth-sized remnant known as a white dwarf. It will slowly cool over billions of years, fading into darkness, a quiet ember of what was once a sun. But for massive stars, the story ends more violently. When the core fuel runs out, fusion stops, and gravity wins a brutal victory. The core collapses inward in a fraction of a second, creating temperatures and pressures so extreme that even iron atoms shatter. The star explodes outward in a supernova, an event so bright that for a brief moment it can outshine an entire galaxy. Supernovae are among the most spectacular phenomena in existence. Immense detonations that scatter heavy elements like gold, silver, and uranium across space. Every atom of iron in your blood was forged in such a cosmic explosion. What remains after such a cataclysm depends on the star's mass. A moderately massive star may leave behind a neutron star, a sphere only a few kilometers wide, so dense that a teaspoon of its material would weigh billions of tons. The strongest magnetic fields in the universe belong to these objects, and as they spin, they emit beams of radiation that sweep through space like cosmic lighthouses. We call them pulsars, and their rhythmic signals, precise to the millisecond, once puzzled astronomers so deeply that they briefly wondered if they might be artificial. But when the progenitor star is truly massive, far heavier than our sun, its collapse goes even further.
Gravity crushes it so completely that nothing, not even light, can escape. What's left is a black hole, a region where space and time themselves bend inward, where the known laws of physics lose their meaning. The boundary of no return is called the event horizon. Anything that crosses it is lost to the outside universe forever, though its gravity continues to shape the world around it. Black holes are not mere voids, they are engines of energy and mystery. Near their edges, matter accelerates to incredible speeds, heating up and emitting intense radiation. Some black holes spin at nearly the speed of light, dragging the very fabric of space-time around them in a phenomenon known as frame dragging. They anchor the centers of galaxies, acting as gravitational keystones that influence the formation and evolution of entire stellar systems. At the core of our Milky Way lies such a giant, Sagittarius A star, a supermassive black hole about 4 million times the mass of our Sun. It sits quietly now, surrounded by swirling stars and dust, but occasionally it awakens, feeding on nearby matter and emitting brilliant flares of X-rays. Using advanced telescopes and arrays spread across Earth, scientists have managed to capture its silhouette, a glowing ring of light encircling darkness. That image was humanity's first direct glimpse of the unseeable, a moment when theory became tangible proof. Yet, for all their darkness, black holes are among the brightest sources of understanding. They challenge our deepest assumptions about physics, gravity, and even reality itself. According to Einstein's general theory of relativity, mass and energy warp the fabric of space-time. Black holes represent that warping pushed to its extreme, a tear so deep that the rules we know cease to function. But according to quantum mechanics, information, the fundamental record of reality, cannot be destroyed. When something falls into a black hole, what happens to that information? Does it vanish forever, or does it somehow survive at the edge, encoded in the faint radiation Hawking predicted would escape? This tension between relativity and quantum theory remains one of the most profound puzzles in science, a place where our understanding still falters at the border between the known and the infinite. The paradox of black holes mirrors the paradox of the cosmos itself, that creation and destruction are not opposites, but partners in the dance of existence. Every galaxy we see is sculpted by the presence of black holes, and every new generation of stars is seeded by the ashes of those that came before. The universe is not static, but alive, a vast cycle of birth, death, and rebirth, played out across unimaginable time. And even our Sun will one day contribute to that eternal recycling. In 5 billion years, it will swell into a red giant, casting off its outer layers in a glowing veil of dust and gas. What remains will be a white dwarf, cooling quietly in the darkness. But from that expelled material, new stars may form, perhaps new worlds, perhaps new life. The atoms that once formed oceans and forests and human thoughts will find new homes, carried by the wind of time into other corners of the galaxy. It's easy to forget, as we sit beneath our modest sky, that all this is happening, that above us, galaxies are colliding, stars are being born, and black holes are consuming entire suns. The stillness we perceive is an illusion born of scale. If you could compress cosmic events into the span of a single day, you would see galaxies twisting like whirlpools, clusters merging, and constellations shifting with graceful urgency. Everything is moving, evolving, transforming, a grand choreography of energy that never truly ends. And in this dance, there is an echo of our own existence. Just as stars burn through their fuel, we too live within cycles of birth, growth, decay, and renewal. The energy that flows through us is the same energy that once powered ancient suns. The hydrogen in our breath, the carbon in our cells, the calcium in our bones, all forged in the crucibles of dying stars. We are part of the same process that lights the heavens. The boundary between the cosmos and ourselves is an illusion drawn by perspective. In truth, there is no separation, only continuity. The night sky, then, is not a distant spectacle, but a mirror. When we look into it, we see not only what lies beyond, but also what lies within. The story of the stars is the story of us, of matter awakening to consciousness, of the universe learning to observe itself. Each photon that reaches our eyes has traveled across time to tell us that story.
If the story of the universe is written in stars, then planets are its punctuation marks. Quiet pauses between explosions, places where matter comes together not to burn, but to endure. Within the swirling arms of galaxies, dust and gas gather in disks around newborn stars, rotating slowly, colliding, merging, and forming worlds. These are the cradles of possibility, where the raw ingredients of existence assemble into the countless planets scattered across the cosmos. Some are barren and frozen, others scorched by relentless heat, and a few, perhaps only a precious few, find a delicate balance where warmth, water, and stability coexist long enough for life to take hold. Our own solar system is one such miracle. It began as a cloud of gas and dust, a remnant of ancient stars that lived and died before the sun was born. Gravity drew that cloud inward, flattening it into a disk with the young sun blazing at the center. Over time, particles of dust stuck together, forming pebbles, then rocks, then mountains of matter that collided and grew into planets. Closer to the sun, only rocky worlds could survive the heat: Mercury, Venus, Earth, and Mars. Farther out, where it was colder, gases and ices coalesced into the giants: Jupiter, Saturn, Uranus, and Neptune. And beyond them even, in the frozen frontier of the Kuiper Belt, lie the remnants of creation. Small, icy bodies like Pluto, drifting in the quiet outskirts of our solar family. But Earth is special. It sits in a narrow zone, not too hot, not too cold, where liquid water can exist. This fragile equilibrium, shaped by distance, atmosphere, and sunlight, allowed chemistry to become biology. In the oceans of a young Earth, molecules joined together, forming structures that could copy themselves, consume energy, and adapt. From there, the slow miracle of evolution began, a process guided not by design, but by persistence, randomness, and time. When we trace our lineage backward, we find that everything alive today, every tree, every bird, every human,
shares a common ancestor, a single spark of life that appeared billions of years ago. It's humbling to realize that the story of humanity is not separate from the story of the cosmos, but a continuation of it. The same physical laws that sculpt galaxies also govern the folding of DNA, the beating of hearts, and the flicker of thought. Life is simply the universe expressing complexity in a new form. And yet, when we look outward, we begin to wonder, are we alone in this cosmic vastness? The observable universe holds 2 trillion galaxies, each containing billions of stars. If even a small fraction of those stars have planets, the number of potential worlds is staggering. Somewhere among them, conditions like ours must exist. Oceans under foreign suns, skies with unfamiliar constellations, perhaps even beings who look up in wonder as we do now. The silence we hear from the stars may not be absence, but distance. The immense gulf of time and space separating one spark of awareness from another. Astronomers have already found thousands of exoplanets orbiting distant stars using techniques as delicate as they are ingenious. Some are detected by the faint dimming of starlight as a planet passes in front of its sun. Others reveal themselves through the subtle wobble of their star's motion, tugged by unseen companions. A few are even imaged directly, faint glowing points lost in the glare of their stars. Among these discoveries are super-Earths, hot Jupiters, and ocean worlds, each expanding our imagination of what planetary systems can be. The Kepler Space Telescope and now the James Webb Telescope have revolutionized our view of these distant worlds. Some orbit within their stars' habitable zones, regions where liquid water could exist. Spectroscopy, the study of light's fingerprints, allows us to analyze their atmospheres, searching for gases like oxygen or methane that could hint at biological activity. For the first time in history, we are not just observing the heavens, we are searching for neighbors. Even if we never find life elsewhere, the search itself is an act of hope, a recognition that we are part of something vast, still unfolding, still capable of surprise. Each discovery reminds us that creation did not end with the Big Bang. It continues every moment, wherever gravity gathers dust into stars and chemistry awakens into consciousness. The Earth, fragile and luminous, floats within that immensity like a single grain of dust suspended in a sunbeam. When Voyager 1 looked back from the edge of our solar system and captured the famous pale blue dot, it showed us just how small our home truly is. All of human history, every joy, every sorrow, every civilization and dream has played out on that tiny speck of light. And yet, in its smallness, there is something profoundly sacred, because that speck is alive. It breathes, it changes, it thinks. In all the universe we've seen so far, it remains the only place where the cosmos has found a voice to describe itself. Carl Sagan once said that the cosmos is within us, that we are made of star stuff. Those words are not just poetic, they are literal truth. The atoms in our bodies were born in stars that died long ago, scattered by supernovae, recycled by gravity into new worlds and new lives. When we breathe, when we think, When we dream, we are continuing the work of those stars, transforming energy into meaning. It's easy in the noise of daily life to forget that connection. We live on a planet that spins at 1,000 miles per hour, orbiting a star that hurtles through space at thousands more, all within a galaxy that itself is racing toward Andromeda at 500,000 miles per hour. Yet here we sit, still enough to watch a sunrise, quiet enough to hear the wind, alive enough to wonder how it all began. That stillness is not separate from the motion. It is born from it. We exist within a moving miracle, and the simple act of noticing is an expression of awe. If we could step outside the Milky Way and look back, we would see our galaxy as a luminous spiral floating in darkness. And somewhere in one of its quiet arms there would be a small yellow star with a pale blue planet orbiting it, home to oceans, forests, and people who look up at night and try to imagine what lies beyond. That image, so distant, so small, is both humbling and empowering. It reminds us that significance is not measured by size, but by awareness. The cosmos may be vast beyond comprehension, but it is through consciousness that it becomes known. And consciousness, in its way, is the rarest element in the universe. Matter is common. Energy is abundant. But awareness, the ability to look inward and outward, to ask questions, to feel wonder, that is extraordinary. Whether it exists elsewhere or not, here, at least, it exists. And that makes this corner of the cosmos special beyond measure. The beauty of existence is that it doesn't require our understanding to continue. Stars would still burn, galaxies would still spin, and space would still expand, whether we ever looked up or not. But the act of looking gives it meaning. To see the universe. Time, in the cosmic sense, is not merely a measure of moments passing. It is the fabric upon which existence itself unfolds. Every second, every century, every eon is a ripple in the great continuum that began with the birth of everything. When we think of time, we imagine clocks, calendars, and ages. But the universe keeps no such record. For it, time is not something to be counted. It is something to be experienced through transformation. Stars burn, galaxies drift, black holes consume, and through it all, the arrow of time moves forward, relentless, irreversible, unceasing. We experience time in a narrow window, confined by the span of a single human life. To us, 100 years seems vast, 1,000 unimaginable. Yet, for the cosmos, such intervals are fleeting sparks. The universe measures its history in billions of years, epochs so long that entire civilizations could rise and vanish in less than an instant. When we gaze at the stars, we are peering into that vastness, seeing ancient light that began its journey long before Earth even existed. In that sense, every night sky is a time machine, a window into the deep past. Scientists believe the universe is about 13.8 billion years old. For nearly all that time, it has been expanding, cooling, and evolving. At first, it was pure energy, a blinding sea of radiation and particles without form. Then, as it cooled, atoms formed, light could travel freely, and the first stars ignited. From those early stars came galaxies, planets, and eventually the conditions for life. In this vast sweep of time, our entire history, from the first human breath to this very moment, is no more than a whisper. But even the universe itself is not eternal. Just as stars are born and die, so too will the cosmos change, decay, and perhaps end. There are several possibilities, each both terrifying and beautiful in its inevitability. One vision is the Big Freeze, the most widely accepted fate. As space expands, galaxies drift farther apart, and the energy of the universe becomes more and more diluted. Stars will exhaust their fuel and die, leaving behind only cold remnants, white dwarfs, neutron stars, and black holes. Over unimaginable spans of time, even those will fade. Matter will decay, black holes will evaporate through Hawking radiation, and the universe will slip into eternal darkness, a sea of thin, cold particles drifting through infinite night. It is not an explosion that ends everything, but a quiet, fading exhale. Another possibility is the Big Crunch, in which gravity eventually halts the expansion and reverses it. Galaxies would begin to move inward, the universe would grow hotter and denser, and eventually collapse back into a single point, a mirror image of the Big Bang. Some theorists even suggest that from that collapse, a new universe could be born, an endless cycle of creation and destruction, expansion and contraction, like a heartbeat echoing through eternity. And then there is the Big Rip, a more violent ending. If dark energy continues to accelerate the expansion of space or grows stronger over time, it could eventually tear everything apart. First galaxies, then stars, then planets, and finally, atoms themselves would be ripped asunder by the stretching of space-time. Everything, down to the smallest particle, would be undone. It sounds catastrophic, yet even that would be part of the universe's natural evolution, the final act in a cosmic story where nothing is truly lost, only transformed. Whichever path the universe takes, it reminds us of something essential. Impermanence is not tragedy, it is the rhythm of existence. Every ending carries the seeds of new beginnings. The stars that die today make possible the worlds of tomorrow. The light that fades now will someday illuminate another sky. Even the death of the universe, in whatever form it takes, might give rise to something beyond, a rebirth we cannot yet imagine. If entropy, the gradual loss of order, is the universe's destiny, then consciousness stands as its brief rebellion. Life, by its very nature, resists entropy for a time. It creates structure, order, and meaning in defiance of the slow drift toward equilibrium. Every thought, every heartbeat, every act of creation is an expression of that defiance. We are the universe momentarily remembering what it means to be alive. And perhaps that is the purpose of awareness, not to change the cosmos, but to witness it. To be the eyes through which existence perceives its own beauty before it fades into silence. When we look at the stars, we are participating in that act of remembrance. adding one more spark of meaning to an indifferent expanse. The universe does not need our wonder, yet it is richer for it. In the far future, when the last light fades, perhaps some form of intelligence, biological or artificial, will still be there, drifting through the remnants of creation. Maybe it will gather what little energy remains, preserving the final stories of the stars. Maybe it will send messages into the dark, hoping that another universe will someday hear them. Or maybe, as everything cools to stillness, memory itself will dissolve, and the universe will forget it ever dreamed. But even then, that it once did, that it once shimmered with galaxies and life, will have been enough. Time has always been both our prison and our gift. It limits us, but it also gives shape to our experience. Without time, there would be no change, no growth, no meaning. The fleetingness of things is what makes them precious. A star's light is beautiful not despite its impermanence, but because of it. The same is true for us. We live for a brief moment, surrounded by eternity, and that brevity gives every heartbeat its value. In the grand timeline of the cosmos, our species has existed for less than an instant. Yet in that instant, we have learned to read the language of the stars, to measure the age of the universe, and to imagine its fate. We have extended our reach beyond the cradle of Earth, sending machines to other worlds, signals to other stars, and dreams into the unknown. We are a young species, but our curiosity stretches across cosmic time. And that curiosity is perhaps our greatest inheritance. It connects us to everything that came before and everything that will follow. Just as gravity holds galaxies together, curiosity binds us to the fabric of existence. It drives us to seek, to learn, to understand. Through it, the universe continues its own story, not just as matter and energy, but as meaning and reflection. There will come a day when the stars we see tonight no longer shine, when our galaxy drifts into a colder, quieter future. But the light that those stars cast will continue to travel, crossing the empty reaches of space for billions of years. And somewhere, perhaps in another world or another time, someone or something might look up and see that light, and in that moment, know that they are not alone. The universe, in that way, is self-sustaining, each spark of awareness lighting another.
When you look into the night sky, you are not simply looking outward, you are looking backward, inward, and beyond. Each faint shimmer of light is a memory, a message from the ancient universe written in the language of photons. The stars above are not strangers. They are your ancestors in a cosmic sense, for their dust became your bones, their light became your eyes. To gaze upon them is to witness your own beginning, a reminder that you are both the observer and the observed, the storyteller and the story itself. There's something deeply human about this act of looking up. It has followed us through every age, from the first fires lit by early humans who traced patterns among the stars, to the astronomers who built observatories on mountaintops, to the satellites that now circle our planet and extend our vision beyond the atmosphere.
Across time, no matter how much the world has changed, that upward gaze remains constant. It is the gesture that defines our species, the moment when curiosity triumphs over fear, when wonder replaces ignorance, when silence becomes meaning. The stars, in their stillness, have always been our teachers. They have taught us patience, for their light travels for ages before reaching us. They have taught us humility, for they remind us of how small we are. But they have also taught us belonging, for everything that exists within us once burned in their hearts. We do not stand apart from the universe, staring at it from the outside. We are woven into it. Every movement of our lives, every thought, every heartbeat is part of its grand vibration. The universe does not speak in words. It speaks in gravity, in light, in rhythm. Yet somehow in our minds, those forces transform into language, into story, into song. We translate its silence into meaning, its darkness into beauty. In that translation, we discover not only what the cosmos is, but who we are. We are the listeners to an ancient melody that began with the first breath of creation, a melody still playing, resonating through space and time, and within us. Perhaps that is why silence feels so vast when we stand beneath the stars. It's not emptiness we hear, it's fullness. The space between galaxies is not absence, it's the breath between notes, the pause that allows the music to continue. We live in that pause, suspended between what was and what will be, between the known and the unknown. It's easy to mistake that silence for loneliness, but it's really connection in disguise, a quiet reminder that even the most distant light reaches us eventually. Every person who has ever lived, every civilization that has ever risen has looked at these same stars. They have witnessed our triumphs, our questions, our fragile moments of peace. Long after we are gone, their light will still fall upon other worlds, upon other eyes. And maybe that's the most comforting truth of all, that the universe remembers us, not as individuals, but as part of its endless continuum. In our search to understand the cosmos, we have discovered something unexpected, that the more we learn about the external world, the more we uncover about the internal one. The symmetry of galaxies echoes the architecture of thought. The birth of stars mirrors the spark of ideas. When we explore space, we are not only mapping the heavens, but also charting the geography of the soul. The boundary between the two grows thinner the further we go. That is perhaps the greatest revelation of all, that the universe is not cold or indifferent as it sometimes appears. It is simply vast, and within that vastness lies every possibility. The same laws that shape black holes also shape kindness, love, art, and curiosity. The same gravity that binds galaxies together binds us to one another. And in that realization, isolation gives way to intimacy. The universe is not out there. It is here, now, in the pulse of your blood, in the spark behind your thoughts, in the quiet rhythm of your breath. Think of all that has had to happen for this moment to exist, for you to be here, reading, breathing, aware. The universe had to expand, cool, and form stars. Those stars had to die, scattering elements into space. Those elements had to gather into planets, and on one of them, life had to arise and evolve until it could question its own existence. You are the culmination of that story. 13.8 billion years of unfolding complexity that led to this single instant of awareness. And the miracle is that you are aware enough to know it. It's strange, isn't it, that something as vast as the universe can be felt within something as small as a human mind. That the same brain that worries about the future can also comprehend the death of stars and the curvature of space-time. We are fragile creatures, yet our imagination spans galaxies. That paradox, that union of limitation and infinity, is what makes consciousness so precious. Perhaps the purpose of life is not to conquer the cosmos, but to commune with it, to feel its rhythm, to learn its patterns, to reflect its beauty back upon itself. Through science, art, and love, we return meaning to the universe. We take its silent chaos and give it voice, give it form, give it emotion. That is our gift in return for existence, to be not only a product of the universe, but also its expression. The more we learn, the clearer it becomes that everything is connected. Every action ripples outward through the web of existence. Every kindness, every thought, every discovery adds to the total story. The photons that leave your body in the form of warmth travel forever. The sound of your voice disturbs the air, and that motion never truly vanishes. It only changes form. Nothing is lost. Nothing is wasted. The universe recycles even meaning. And maybe that's why we keep looking up, because somewhere deep within us, we recognize the stars not as distant points of light, but as reflections of home. The pull we feel when we gaze at them is not longing for another world. It is the memory of where we came from. We are returning in thought to the source that gave us being. So let the vastness comfort you. Let the mystery humble you. Let the silence remind you that you are part of something eternal. The stars above you, the atoms within you, the thoughts that drift between them, all of it is one. And when your life feels small, remember this: smallness is not insignificance. A single candle can illuminate a dark room. A single heartbeat can echo the pulse of galaxies. A single mind can contain the reflection of infinity. The universe does not measure worth by size or duration. It measures by awareness, by wonder, by the simple act of noticing. One day our sun will fade, our planet will cool, and the traces of humanity will drift into memory. But the story will not end there. Somewhere new stars will rise, new worlds will form, and perhaps new beings will awaken beneath new skies. They too will look up, and in their gaze, the universe will recognize itself once more. That is the eternal cycle, not of destruction or despair, but of renewal. The cosmos does not vanish, it transforms. Light becomes life, life becomes thought, thought becomes memory, and memory becomes